Okay, so hi everyone. Today we are going to solve this two sum 2 problem, which is in which that the input array is sorted. So if you have seen the first problem, two sum part 1, you know that we can solve this in big O of n and big O of n time complexity as well as big O of n space complexity. Also we can do this in big O of n square time complexity and constant space complexity. But in this video everything is same, that there is exactly one solution. We have to return the indices of those two numbers, and but the only thing is the input is in this case sorted, and we somehow need to use this sorted property. So what I can do is, right, so this problem, you need to solve this problem, because if you solve this, you will be able to solve the three sum problem, right? So that this problem is basically a prerequisite for the three sum problem. So what I would do is I will keep a track of two pointers. The one will be in the starting, the second one will be in the end, and we will check and compare these elements if they equal to the target or not. And while I write the code, I will explain what I am trying to do. So when we increase a particular pointer, so first of all, let's say int of I is equal to 0, int of j is equal to numbers dot size and -1. So because these are indices, so 0 based indexing. Okay, so if you see, you also need to return the answer with 1 based indexing. Okay, that is different, but we can actually handle that. Let's say we don't find a solution, so what do? I return -1 comma -1, but given this constraint exactly one solution, so you know that you will never reach this return statement. Now what I do is, while I is less than j, right, we don't want a case where we are returning the same index twice. Okay, so the only thing different is from part 1 is this, that you don't need extra space, but you can still achieve the same time complexity. And the reason for that is, you know that the input array numbers is sorted. So I say int sum, the sum that I get is target of I plus target of j. Fine. Now if and only if sum is equal to, so this is not target but numbers, so if this is equal to target, that means we have our solution, right? So what I do is return I and j, but we cannot return this directly because we need to return 1 based indexing, and we are currently using 0 based indexing. So I just add 1 to both the numbers and this should be good to go. But if that is not the case, elif, or just you can write if as well, because it's one and the same thing in this case, because we are returning in this first statement itself. So if sum is less than target, what does that mean? It means that this numbers of I plus number of j is less than target, right? So that means this number of I is way too small to accommodate this target, to sum up to this target, right? So what I want is, I want to increase the smaller number, right? So what I do is I say I plus plus, so I increment the I and do this process again. Otherwise, if sum is equal to target is done, sum is less than target is also done, but the last case is sum is greater than the target. That means numbers of I plus numbers of j is greater than target, which means that this number is too large now when added with this I, numbers of I. So what we need to do is to decrease the value of the sum. So how do we decrease? We decrease by decrementing j, because we know the array is sorted. So that is why the element smaller than or equal to numbers of j would be at a position j minus 1. So what I do is I say j minus minus, and Yep, this is the answer to this question. Okay, sorry for the error, but my net got disconnected. So if I just run this, let's see if this is working fine or not, or are we missing something, right? So accepted, this is working fine. I just check all the test case and I'll just submit this answer. So yeah, okay, that was the video, guys, and if you enjoyed this, be sure to subscribe if you have not done yet, and even if you don't want to subscribe, please share this video with someone who you think would need this. And yeah, anyways, I'll see you in the next video, and